The speed of light in a vacuum is the absolute speed limit of the universe. As you accelerate towards it, any object with mass suddenly finds it has a lot more of it, and so it takes more and more energy, eventually infinite amounts of energy, in order to move towards it. It's disappointing. There's a lot of universe to explore, and it would be nice if we could reach some of it without sending generational ships or waiting hundreds of years for signals from probes or human explorers. Enter the warp drive. While objects with mass are forbidden from reaching and exceeding the speed of light, regions of space can move away from each other at speeds faster than the speed of light. See the expansion of the universe for more details. Warp drives, popularized by sci-fi show Star Trek and hypothetically explored by scientists, notably Mexican theoretical physicist Miguel Alcubierre afterwards, theoretically get around the annoying speed of light by wrapping a ship in a bubble of space-time. The ship would remain stationary within this bubble, while the bubble itself can travel at superluminal speeds relative to an observer outside it. By a purely local expansion of space-time behind the spaceship and an opposite contraction in front of it, motion faster than the speed of light as seen by observers outside the disturbed region is possible. Alcubierre explains in a paper, the resulting distortion is reminiscent of the warp drive of science fiction. However, just as it happens with wormholes, exotic matter will be needed in order to generate a distortion of space-time. There have been attempts to reduce the amount of exotic matter required or question whether it is necessary. Even if one believes that exotic matter is forbidden classically, it is well known that quantum field theory permits the existence of regions with negative energy densities in some special circumstance. For example, in the Casimir effect, Alcubierre continues, the need of exotic matter therefore doesn't necessarily eliminate the possibility of using a space-time distortion like the one described above for hyperfast interstellar travel. Some teams have attempted to model what we could do without any exotic matter and claim that it could be possible to use traditional and novel gravitational techniques to create a warp bubble within the bounds of known physics, though this would still hugely challenging, require a lot of energy, and likely only able to travel at speeds lower than that of light. So that's settled. All we need is some exotic matter, a few technological revolutions, or some less exotic matter and a few technological revolutions, and we have ourselves a working warp drive. Time to play Star Trek, right? Well, probably not. There are problems with warp drives. That could mean they are forbidden by those pesky laws of the universe. One is that they could sweep up matter as they traverse the universe, which then gets unleashed once you decelerate. This means that you could arrive at your destination and find that you've obliterated it. But say you aim slightly to the left of your destination and don't really give a hoot about destroying a bunch of matter in some backwater region of space. There are still other problems that arise from faster-than-light travel, which could end with you breaking causality. In short, if faster-than-light travel can occur, then observers in different reference frames begin to disagree about the order of events. For a simplified example, imagine a warp ship coming towards you at twice the speed of light from your vantage point. The first you would see of the ship would be when it arrived, as the light from its starting point has not yet reached you, but that light would reach you, with the light from nearer to you points in the journey reaching you first, and then backwards until the journey began. The result would be that you would see a ship suddenly appear, and then flying away from you at the speed of light. Given that there are no absolute reference frames that override others, this is a problem, and it gets worse to the point of really breaking reality if you involve multiple observers and faster-than-light communication. Something will likely prevent us from breaking the universe, and we will probably find that we are limited by the speed of causality. But for now, let's hope someone will make it so.